Hey everyone, Matt Lewis here, developer advocate for Amazon Web Services, and this is CMP 310 or AWS Outposts, an in-depth look at hybrid cloud use cases. So we're going to be talking a whole bunch about AWS Outposts today, and Outposts launched last year at reInvent, so it's been about a year and we've got a whole bunch of content to cover here. So before we get into the architectures themselves, we do need to talk about the foundations of Outposts. And this is just so folks have a little bit of an understanding of how Outposts works and some of the thoughts that went into when we built AWS Outposts as a service. So to start with, AWS Outposts is the same AWS designed infrastructure as we use in our regions. And so what we've done over the last many years is building our data centers, the technology that's gone into that. We've now taken that and put it into a single rack or multiple rack form factor. So what we can then do is offer that as a service to customers like yourselves, where you can run AWS services on premises. It's actually pretty amazing. I'm super excited about Outposts, and having the ability to run AWS on premises has just been such a game changer. So Outposts isn't just like having AWS hardware on premises, it's actually a fully managed service. So it's owned and operated by AWS, but it operates at your site. And so we'll get into things like the VPC networking and how you deploy things like applications on an AWS Outpost. But the underlying physical hardware itself is managed by AWS. So any underlying software updates to the hardware itself, that's all managed by AWS. And so when you're using the Outposts, we use the same single pane of management as what we use in the region. So you'll log in through the console or use our CLI or use API calls, and you're able to manage and use the Outposts and the applications on the Outpost by the same tools that you would use inside the region. So this single pane of management operates within the region and across Outposts as well. So if we just take a second here to look at the Outpost hardware, on the left-hand side or one side of our slide here, we've got a 42 RU or rack unit rack. And so it is 24 inches wide. I do get a lot of customers that ask, how wide is the rack? Is it a 19-inch rack or a 24-inch rack? It's actually a 24-inch rack. And in the center here, you can see we've got our patch panels, we've got our hosts, we've got our network switches, and then our power shelf, and then more hosts. And so some of the photos you would have seen of an Outpost, and you can kind of see it on the rack picture here, we've actually got the hosts and the network switching in the center of the rack. And the reason why we do that is so in the future, when we have the ability to do things like capacity infill, so adding more hosts to an Outpost, they might be heavier than the existing hosts that are in a rack. So we leave that bottom of the rack free. Now on the right-hand side, we've also got our bus bar, which is basically part of our power shelf that feeds power into the servers and the equipment inside the rack. So that's something that's just a little bit different from what you might be used to in a standard data center arrangement where you're plugging in things like an AC power cable or maybe some DC power. We use this bus bar to distribute the power within the rack. One last point here as well, we do have our patch panels at the top of the Outpost rack. You'll connect fiber into those patch panels. So when we talk about the network architecture, that's where you'll be plugging those fibers into, and we're going to talk more about that today. Okay, some of the use cases. I think one of the most popular use cases when I talk to customers is low latency. So it's the ability to have AWS services operating locally in your data center at your premises. So things like EMR, Elastic MapReduce, things like EC2, EKS, ECS, and now also S3, RDS, our relational database service, they can all operate in the Outpost. And we have this new gateway type, which I'll talk about, called a local gateway. And the local gateway gives you access to your on-premises data center for all of those services. So having really low latency connectivity to AWS services is really key with the AWS Outpost. So the next is application modernization. Now, I touched on this a little bit, where you can do things like have CloudFormation or have a JSON file that describes your infrastructure, and that can be used to deploy your Outpost deployment or your application stack on top of the physical Outpost deployment. And so using things like CloudFormation, auto-scaling, application load balancer inside an Outpost, and really modernizing your application deployment is something that's really, really easy with an Outpost. And so When I talk to customers as well, a lot of customers always ask, hey, when are you going to deploy a region in X location? And so we have 24 regions right now, and we still get customers asking for AWS in particular locations. So for data residency or data sovereignty, for example, you might want to deploy an outpost in a particular area or geographic location, so then you can run those services and keep that data in that location. And lastly, we have local data processing, where you might be doing something like using Amazon EMR or Elastic MapReduce locally inside the outpost at your on-premises, and you're connecting through to maybe something like a data lake or some other form of data repository inside your data center, and that's allowing that low latency connectivity to your local data processing at your location. Okay, so the outpost itself is built on the same Amazon EC2 instances and Amazon EBS volumes as we use in the region. So when you look to purchase an outpost or choose what type of outpost you want to deploy, we actually have 22 different available configurations in our product catalog. And so they're a combination of things like our C5 or our M5 family of instances. So if you had a compute heavy workloads, you could choose a C5 heavy outpost deployment. Or if you wanted to use something like a G4 or you wanted to use graphics workstations or something similar in the outpost, you could have a configuration with G4s, or maybe IO intensive, you could use our i3. So there's a couple of different families of instances available in the outpost, and they're all using our Intel processors. And so when we talk about using our Intel processors, essentially we're built on the same Intel Xeon processors as AWS, as the AWS cloud or our regions. And so that's going to give you a consistent application performance when you're using an outpost or maybe using an AWS region. That also does give you an ease of application migration. So you're not migrating to a new application or new processor family that needs you to rewrite any code or anything like that. So it's all the same Intel processors. And we're using a few different families here. We're using the Skylake, Broadwell, and also our Cascade Lake families of processors in the outpost, just like the AWS region. So when we think about outposts, I think the main takeaway here is the reason you'd want to run an outpost is for running Amazon services locally. So things like compute, our EC2 or EBS volumes, so compute and storage, networking such as our VPC, which we'll talk about, databases, containers, data processing, and very recently we did release Amazon S3 for AWS Outpost. So you can now have an S3 bucket or object storage locally inside the outpost. And so again, we'll talk more about this, but you do have the whole range of services in the region that's able to communicate with the outpost, and you're able to use things like EC2 auto-scaling groups or CloudFormation or CloudTrail or Elastic Beanstalk, and all of those services that operate in the region can connect through and function alongside the outpost as well. Okay, that's our foundational component of AWS Outposts. And so we've talked a little bit about what Outpost is and why you might want to use it. And we'll dive more into some use cases towards the end of this session. But what we now need to do is talk about the networking layer. And before we do talk about the networking layer for Outposts, let's talk about Amazon VPC networking. And so when we're building inside an AWS region, and I'll go a little bit fast here because I want to focus on the Outpost, but this is really good foundational background on Amazon VPC and how that operates. So we have an Amazon VPC, it operates inside a region. It's a region level construct until Outposts. Now we then have availability zones. We have our subnets, public subnets and private subnets that operate inside the VPC inside the region. And so we might deploy some things like our EC2 instances or our compute. And then we have these other services that sit outside of the VPC, such as S3, DynamoDB, etc. We might connect to the internet. And if we look at what an architecture looks like from a regional networking perspective, we have route tables for our VPC. And so as we build out different services, we want to build out those route tables here, and we'll build them out here on the slide. And so if we want to connect to the internet, we have a default route to our internet gateway. Then we have things like an Elastic IP, which allows the instance to talk with the public internet or public services. We might be using things like a NAT instance or potentially NAT gateway, hopefully. NAT instances don't scale that great because they're just a single instance doing NAT, but NAT gateway is actually amazing for doing large-scale NAT. And as we kind of build out our topology, you notice we're building our traffic flows. We're thinking about what instances or things will talk to other things within your VPC and within your AWS deployment. And so we might use gateway endpoints to connect to DynamoDB or S3. We might use a VGW to connect to your on-premises. And we'll talk about Direct Connect in a moment with Outposts. But you could use Direct Connect Gateway or Direct Connect. You might be peering with other VPCs. You might be using Transit Gateway to connect to up to 5,000 VPCs or on-premises via VPN or Direct Connect. And we also have VPC flow logs, so giving you some metadata on the traffic inside your VPC or going in and out of your VPC. We have Private Link. We now support a whole range of services with Private Link to drop those services privately into your VPC. AWS Global Accelerator, which sits outside the VPC, traffic mirroring traffic, and there's a lot of stuff here, but I'm just giving you a very high-level overview on what an AWS architecture would look like. We might have ingress routing to a firewall instance, and then maybe client VPN. And lastly, which we're going to talk about, you've got AWS Outposts where the VPC is actually extended to the Outpost. So that same topology that you had inside the region, using all of these components, you're now extending that down to an Outpost which is deployed at your premises or on premises. So I've given you a quick overview on all of the AWS services, and normally it's not really possible to fit all of our networking services into one slide. That slide's a little bit busy, but let's talk about AWS networking for Outposts. And so when we start talking about the networking for Outposts, we've essentially got the same VPC that we had in the region, but now we're extending that down to the Outpost. So you've deployed an Outpost. It might be a single rack or multiple racks that's sitting on premises. When that rack comes online, you can create Outpost subnets inside a pre-existing or maybe a new VPC. And so we create our Outpost subnets here, and then we can deploy our EC2 instances inside those subnets, and they're now sitting on the Outpost itself. So you're using Outpost EC2 in this case to deploy these instances. And so the beauty of us using VPC, just like the region, is it will give you access to the same components that you could use to manage your AWS deployment. So things like route tables, security groups, NACLs, they all operate inside the Outpost just like they do in the region. So if you're familiar with VPC architectures, this is going to be pretty familiar for you folks. Okay, so when we talk about traffic flow inside the Outpost, instances can obviously talk to other instances inside the Outpost. They can also communicate with other instances in the region inside that same VPC. And so what we can actually do here, if I just build out the route table of the Outpost, we've got this thing called the local route, and in this case it's a 10.1.0.0/16, and that's allowing everything to talk to everything else inside that VPC, even if it's in the region. And then we add on our components just like we did in the region, in our previous slide in the region. Now, an internet gateway is a region-level construct, just like a VPC endpoint for Dynamo or S3, or even our interface endpoints for Private Link. Transit Gateway, which is an immensely popular service, one of my favorite services, allowing us to build a whole bunch of scale in AWS. That operates inside the region as well. VPC peering, VGWs, etc. And you'll notice here we're building out our route table on the right-hand side that's allowing us to communicate from the Outpost to all of those other entities. Now, as I said before, one of the main reasons you want to use an Outpost is connecting locally or to in low latency to local workloads that might be operating on premises. And so we did build this new type of gateway called a local gateway. And the local gateway sits inside the Outpost. Each Outpost gets one local gateway. It's a logical construct, just like an internet gateway in the region. There's a whole bunch of redundancy that goes into the local gateway itself. But you'll essentially attach that local gateway to your VPC, and that's going to allow you to connect to your on-premises workloads. So we'll build a route here via the local gateway, and we actually have what's called a customer-owned IP or a COIP range that you'd have for your Outpost that you address your instances and other services inside the Outpost from your on-premises address range. So that allows us to connect to your on-premises here. Or if you wanted to, it's just up to routing. You could route anywhere else you wanted to go within that region or within your on-premises. Now, if we talk about local connectivity, we've essentially got our Outpost devices, which are the switches you saw in the rack photo earlier. They're sitting in the center of the rack and they're connected to your devices. So again, there is a demarcation there at the patch panel where you'll plug fibers into, and then we'll use things like LACP or Link Aggregation Control Protocol, and that's going to allow us to have multiple connections per Outpost device to your switching infrastructure at your premises, and that's going to allow us to have a bit of capacity and redundancy there. So we can have 1 gig, 10 gig, 40 gig, or 100 gig connected from the Outpost through to the Outpost or through to your devices. And you'll notice here we do split it out into 2 different legs for redundancy. And so if we build out our LAN connectivity here a little bit, we do have 2 different paths, the service link path and the LGW path. And we use VLANs, just standard virtual LANs, to split those 2 for the service link, which is what we call the connection back to the region, or the LGW connection, which is the connection on premises. And so we use BGP to advertise the routes from the Outpost, and then the LGW is attached to the VPC and basically bridging through to your on-premises there to your LGW. And so we've essentially got our routing inside the VPC itself, and the VPC routing is separate from what you would actually do on premises to the Outpost as well. So there's a little bit of segmentation there too. Now, coming soon, we will have the ability to, instead of using customer-owned IPs at the LGW, and so that's really where you bring an address range from your data center and you use it like Elastic IPs to assign to the instances in the Outpost. With direct routing, we'll have the ability to advertise the native subnets of the VPC inside the Outpost out to your on-premises, so there's no NAT there anymore. Like if I think about the COIP model, it's more like an internet gateway, or with direct routing, the model is more like a virtual private gateway or a VGW where there's no NATing, so very similar there. If you were interested in some topologies here on how to connect to your on-premises and what the potential Cisco or Juniper architecture could look like if you're using any one of those vendors, feel free to grab one of the links here or scan one of the QR codes. We've got some reference architectures that are worth checking out that Juniper and Cisco published. Connectivity back to the region is definitely something that's important for the Outpost. So when we talk about that, we've essentially got the Outpost and it's an extension of an availability zone. And so what that means is when you deploy an Outpost, you'll choose an availability zone to home your Outpost from. So what we'll do is build what we call the service link over a WAN connection, either a direct connect public virtual interface or an internet connection. And so just as I build this thing out here, you'll be wanting to connect to what we call the Outpost server or our Outpost service, or what we call our anchor endpoints inside the region. And so what that will allow us to do is via the public IPs assigned to the Outpost anchor service, we'll build a set of encrypted tunnels from the Outpost to the region, and that's how we extend the VPC, and that's also how we do control plane connectivity down to the Outpost. And so you can see here that we've got our control plane connectivity, but we're also dropping connectivity into the VPC via that Outpost anchor, and that's how we're extending that VPC to the Outpost. And so a couple of things to consider with the connectivity back to the region. We do ask for a minimum of a 1 gig connection, but you can connect publicly over either the public internet or a public virtual interface. Now, coming soon, we will also have the ability to have private connectivity for the Outpost. And in this case, we'd actually take a VPC that you own. We'd connect a private virtual interface, or you would connect a private virtual interface to that VPC, and we'd then drop the Outpost service into that VPC and allow that connectivity. So in this case, you actually don't have the anchor service being public over a public virtual interface, it's over a private virtual interface. All right, let's dive some more into VPC architectures for the Outposts. And so when we think about the service link, essentially we've got the service link that's extended from the AWS region from a particular AZ that the Outpost is home to. And then when we deploy multiple VPCs in the region, for example, you can also deploy things in the subnets inside those VPCs in the outpost. So you can have multiple VPCs in the outpost. And when you're communicating back to the region or extending that connectivity from a VPC, that's all going to go over the service link. Now, what you could do is, if you were really interested in redundancy, and we always talk about deploying in multiple availability zones and that sort of thing, you could deploy multiple outposts and home them back to separate availability zones. So in this case, we've got the same VPCs, but we're actually extending those to two different outposts that are home to two different availability zones. Now, one thing to point out here is we don't actually allow intra-VPC traffic if you had one VPC spanning both outposts, in this case, to traverse from one outpost to the other. So it's basically meant for communication from the region to the outposts themselves, and it's just not a good idea to be tromboning traffic through the region when you're going from one outpost to another. And so that leads us into some VPC routing architectures here. And so when we talk about the outposts and VPCs, you can have an isolated VPC inside an outpost. But do keep in mind that if you use EKS or Transit Gateway or other services, we're dropping connectivity to those services into your VPC in the region. So communication will go via that VPC. And so in this case, we might want to use VPC peering with one outpost and multiple VPCs. Normally, VPC peering sits in the region, but in the case of an outpost, VPC peering would actually remain inside the outpost itself. So we're able to take VPC peered traffic between two VPCs in the same outpost and keep that traffic locally inside the same outpost, which is definitely very convenient, much more convenient than going back to the region, and which is obviously going to be a performance and latency hit. Now, if we had a transit gateway, which again, very popular service and one of my favorite services, just allowing you to have that large scale VPC connectivity, up to 5,000 VPCs in a region, and now peering to other regions as well. But if you did connect to a transit gateway like we've got here, the traffic would go through the transit gateway, but it would go through the region as well. And that's going to add a whole bunch of latency. And you're going from the outpost to the region back to the outpost, which probably isn't a good idea to do. Now, the better way to do things here, if you had multiple VPCs, is probably to use the local gateway and use your local networking. And so what we've got here is a local gateway. We've got our route table sending traffic to the local gateway, and we're then using our customer-owned IPs to communicate from one instance to another across two different VPCs. Now, in this case, we've actually got two separate outposts with two separate local gateways. Remember, when we have an outpost, you have one local gateway, logical entity again, but with two different outposts in this case, we can actually do this and communicate from one local gateway to another via your local network. So communicating between the outposts here, maybe they're at opposite ends of a data center or maybe a manufacturing shop floor or something like that. You could use the local gateway to communicate from one outpost to another, and that's going to be a lot more performant than going back through the region and using something like a transit gateway. Okay, so let's talk about some reference architectures here. And so when we think about low latency, a classic example for low latency is online games. So online games essentially like to group users together that connect all back to a particular game server. And if you wanted to deploy an online games server in AWS, you can, and customers do. And in this case, what we've actually got is customers that are connecting to a session state server and maybe some game servers using DynamoDB as well, maybe some Lambda, maybe having some game runtimes operate inside S3, for example. And you see there's a little bit of variance in latency between users. So we've got 15 milliseconds with one user, but we've got 55 and 60 milliseconds with other users. And so what that actually looks like is something like this, where we've got our regions in North America, for example. I just used North America as a quick example here, but we might have clients set across the country, and they're all talking back to a particular region that has the game servers that are hosted. And so you see the variance here, that you've got some users that are very close to the region, but others that are much further away from the region. And now, because they're grouped on the same server, they're going to have a bit of inconsistency when they're playing on these online games servers. So what we can do with the outpost is deploy an outpost here in the center of this geographic area. And now the clients are connecting to the outpost, and they have a lot more consistent latency across the users themselves. So they're all within that closer geographic region. And so if we look at what the architecture looks like here, we've essentially got the outpost. We've extended the VPC from the region to the outpost, or we're running things inside the outpost inside that same VPC. We're still using things like DynamoDB and game runtimes and all that kind of stuff in the region. But now we've actually got S3 inside the outpost that is locally caching game runtime. So you've got a better performance when you're spinning up your game servers and that sort of thing. You've got your game servers running inside the outpost. You're using the LGW. You're using some networking to connect to that LGW. And your users have a much more consistent experience across the from the users themselves back into the locally deployed outpost deployment for online games. So it's actually pretty awesome. And so this actually works really well with game streaming. So with game streaming, the users do need to be very close and have a high performant connection from the mobile devices, for example, to maybe some G4 instances that are running inside an outpost. And in this case, we've essentially got some users that are connected from their mobile devices back to the outposts and using that service to operate in a performant and low latency manner. Okay, so application modernization. When we think about application modernization, I think about when I first started using AWS. It's been about probably 7 or 8 years ago now. But one of the things that blew my mind was auto scaling, and we'll talk about that. But CloudFormation to start with, basically, you can define your deployment as a JSON file and deploy your deployment in a matter of minutes. And that's really what cloud is about. It's what AWS is about, deploying many infrastructures really easily, globally. With Outposts, you can still use CloudFormation as well. But then we also have things like application load balancer, S3 storage locally in an outpost, Amazon VPC, which we've talked a whole bunch about, and then lastly, auto scaling inside the VPC, inside the outpost. And so what you can do now is you've essentially got servers that are on premises managed by AWS inside an outpost rack, and you've got instances operating on top of that hardware, and you can scale out or scale in or horizontally scale those instances depending upon your user demand. And so auto scaling was one of those things that really blew my mind when I first started thinking about AWS. And it was like, I don't have to wait 6 months for a deployment for new servers, right? You can do that on premises now with AWS. And we're not limited to just these services. We can obviously do the whole range of AWS services that operate in the region can interact with the outpost for how we've built the VPC itself and extending that VPC. And so if we look at a quick architecture here, on how the application modernization deployment would look like. We've still got things like Dynamo and Lambda and CloudFormation that are operating in the region. And so the outpost connects back to the region and is able to interact with these services. But we're also deploying things inside the outpost here where we've got S3, so our object storage in the outpost. We've got some EC2 that we might be using. We've got our local gateway giving us local access. And then we've got an ALB, an application load balancer, running inside the outposts. We can also then have our instances operate inside an auto-scaling group. So we're using ALB, we're using auto-scaling, and we're doing it all on premises. Pretty amazing, pretty awesome stuff. Okay, our second last architecture that we have here, data residency. And this is probably one of the simplest ones when I think about it in terms of technical prowess as far as deploying the architecture itself, but it's actually one of the most important to a lot of customers. And so there's a couple of things to consider here with data residency. When we have an outpost, it's deployed in a particular area, and where, let's just say you've got some data sovereignty, or for various different reasons you need to deploy and keep all of your data within state lines or within a particular geographic area. So you've got your users inside that same geographic area interacting with the outposts. And so Things like S3 inside the outpost, we're not going to push that data up into the region. Things like your EC2 instances, your EBS volumes, your EKS, your EMR, all of that data operates inside the outpost. But there are a few considerations that you might want to think about, in that the outpost will send metadata back to the region. And so again, it is a managed service, and the metadata is really around our management of the hardware itself. And so interacting with things like CloudFormation and CloudTrail and Transit Gateway and other services in the region will mean that the outpost is communicating back to the region. But you do have the means now to have things like a local S3 bucket inside an outpost inside a particular geographic region. Super amazing. Okay, our last use case here, local data processing. I've got an architecture for you folks, and we actually did just release a manufacturing for Outposts reference architecture on our reference architecture site. And so this architecture is where we've got our PLCs or our PI interfaces, or our, I think our PLCs are programmable logic controllers or something in a manufacturing facility, and they need to communicate with a database or something else in real time locally. So in this case, we're actually using OSI Pi and using things like Pi Vision and domain controllers and SQL servers and our Pi data archive and those kinds of things locally inside the outpost. But because we've got the outpost as an extension of an availability zone that does need an always-on connection, but it is also interacting with the region level deployment of our OSI Pi system as well. So now we're using the outpost for local data processing. In this case, we're using it for manufacturing, and we've got an outpost next to our manufacturing shop floor, or maybe in a data center that's right next to the manufacturing facility. Not all manufacturing facilities have the ability to have a data center like rack next to the actual, manufacturing line and that sort of thing. So, but some things to consider. And so in this case here, you can see that the Pi interfaces or our PLCs are actually communicating with the outpost via the LGW locally. All right, so there are 4 main use cases, and I have a reference architecture here that I want you folks to take away. We talked about VPCs and networking architectures for AWS Outposts. We talked a little about the regional level networking stuff. I'm doing another session here, Net 309 or Advanced VPC Design. Feel free to come along to that to learn more about the region level networking. But for networking inside the outpost, we have this reference architecture, and don't feel like you need to investigate it all right now. There's a whole bunch of content in here, but this is something we released a couple of weeks ago, where essentially it gives you all of the details that you need to connect from an outpost to your local networking, but then an outpost back to the region as well, and how all of those components sit together. And so if you're interested in that, we've actually got a quick link here. It's a QR code. Feel free to scan that with your mobile device, and that'll take you to that reference architecture where you can download that and view it in your own time. There's a lot of details in that thing, but feel free to grab that through the QR code here. And that does lead us towards the end of this session here. I have some more resources for you. So if you're interested in learning more about AWS Outposts, we have the How AWS Outposts Works documentation. There's a whole bunch of detail in there. We've also got our Outpost overview, and then a more resources tab where you can check out some more resources on AWS Outposts. And they're all just QR codes that you can scan again with your mobile device, or maybe use the shortened URL there if you're quick enough to grab those. And lastly, this wouldn't be a reInvent session without plugging other sessions which I think are actually amazing and are definitely worthwhile checking out. So we have Net 202, our Go Global with AWS multi-region network services. We've got Net 203, demystifying data transfer. There's a couple of others there with shared VPCs and working with marketplace partners. But I've thrown the last 2 in there, are 2 of our other Outpost sessions that are worthwhile checking out. Our Cloud Where You Want It with Joshua Burgeon, our GM for Outpost, definitely worth checking out. And then AWS Outpost, bringing the AWS experience to on-premises, which is actually with one of our senior principals, Anthony Ligori, who did a whole bunch of the underlying architectures and build on the way Outpost works. So that's going to be a super interesting session to check out. That was CMP 309. So lastly, thank you. Thanks for watching. Really enjoyed presenting to you folks here today. I know there was a bunch of detail in there. I hope it was definitely useful. And don't forget to fill out your session surveys. We really do read every comment that you folks post in the session surveys. And I use that every year. I think this is my 5th reInvent this year. And I'll use it every year to basically build upon my sessions and take that feedback to heart. So definitely be kind, but critical as well. And it's much appreciated if you could fill out the survey. Thanks very much.